right, so we're going to take a look at week 9. Okay, week 9 is on radicals, and this will be really, I think, the last week that we do anything that's not review before midterms. Okay, so we don't have a midterm in this class, but next academic week, because you do have midterms in all your other classes, we might do more review in this class. I'll double check with the teacher that plans it, but I think that's what we'll probably end up doing, just review. So we're going to look at simplifying radicals. And first of all, there are many ways to do it. So if you have a method that you already use to do what I'm showing you how to do, and your method works, I would just stick with your method. If you have trouble simplifying radicals and you don't know how to do it, then I would pay attention to what I'm showing you, and you can use my way. All right? But there are different ways to do it. So the first thing is, when you are simplifying the square root, the way I'm going to show you how to do it is you're going to take the number and you're going to break it up. You're going to break it up into two numbers. Okay? The two numbers have to multiply together to give you the original number, and you have to use a number in this list. 4, 9, 16, 25. Does anybody know what those numbers are called? I need to fix one of them. This one, just change this to a 36 on your notes, not 26. Does anybody know what those numbers are called? Yep.
Are they prime?
They're not prime. It does begin with a P, though. They are yeah. Perfect squares, yes. These are all numbers. Again, change the 26 to a 36 on your notes. That was a mistake. These are all numbers that you can take the square root of easily in your head. Okay? So when we break a number up into two numbers, you have to pick a number that is in this list. If you need to go higher than 81, you can. And on the back of your notes, if you look at all these numbers, this chart will help you go higher than 81 if you need to. Okay, you're looking at all these numbers right here. These are the numbers I just circled that are in that list on the other page. Okay, and I go pretty high. I go probably higher than you're ever going to need to go, but you got them all in the back of your notes, so that should help. So let's just practice writing a number as a product of two numbers. Let's start with 20. Does anybody see a way that you can write 20 as something times something, and one of the numbers has to be in that list? Yep.
5 times 4?
Yep, 5 times 4. Okay, I'm not showing you how to simplify it yet. I just want you to get practice writing it with a number in that list. How about 50? Does anybody see how you can write 50 as something times something, and it's got to be a number in this list? One of the numbers. Yeah?
Was it 4 and 25?
Uh,
I was going to say something.
So something in 25, yep.
25 and 2.
25 and 2, yep. Okay, I'm going to show you the next step in a minute. Let's just do one more of these. How about 80? Anybody see how you can write 80 as a product of two numbers, and one of them has to be in that list? Yeah?
16 times 4.
16 times 4, that would give you 64. 6. But we might be able to do 16 times something else.
16 times 5.
Yeah, and if you're not sure, we could just take our calculator and we'll see. No, I think we got it before, 16 times 5. But if you're ever not sure, just use division to check it. Yep, 16 times 5. Perfect. Right. So that's the first step. Take your number and break it up as a product of two numbers. Now, let's do these same 3 again, but let's try to take the square root of them. Okay. So the first step to take the square root of 20 is to break it up into 2 square roots. When you break it up into 2 square roots, it's going to be these 2 numbers that you just figured out, 4 and 5. So you break it into 2 square roots, and those numbers have to multiply together to give you 20. Now, which one of these can you simplify in your head? The square root of 4 or the square root of 5?
4.
Yeah, what's the square root of 4? 2. That is how you do the problem. 2 square root 5. Another thing you can do to check your answer to make sure you got it right is type in the original problem, square root of 20. Look at what you get. Now type in the answer you just wrote down, 2 square roots of 5. What do you notice about them?
Same thing.
Yeah, they're the same thing. And they should be. If they're not the same thing, then when you did your problem out, you messed up. Okay, the original problem and the final answer should come out exactly the same. Okay, let's try square root of 50. Okay, we're going to break it up into 2 square roots. And what are the 2 numbers that we're going to use to multiply and give us 50?
25 and 2.
We're going to use a 25, and we're going to use a 2. Now, which one of those can you take the square root of easily without a calculator?
25.
Yeah. What's the square root of 25? 5. There you go. That's your answer. Okay. And again, I'm not going to check all of them, but I can check it. Type in the square root of 50. You get that number. Type in your answer. 5 square root of 2. You come out exactly the same. That means your answer is equal to what you started with, but it's simplified. Right? And let's do 80. Break it up into 2 square roots. What are 2 numbers that multiply to give me 80? Yep, what we just figured out up above. 16 and 5. Okay, which one of these can you take the square root of easily in your head? Yep.
16.
16. What's the square root of 16?
8.
Does
Oh,
8
4.
times 8 give you
4.
16? Yeah, 4.
Duh.
I'm sorry. 4 square root of 5.
Sorry.
Yeah, you were thinking of 8 plus 8, not 8.
Yeah.
Yeah, that's okay. Now, when we multiply 2 numbers to get 80, does 4 times 20 give you 80? Yeah. So this is the best way to do it. But let's say somebody did square root of 80 and they did it as 4 times 20. Let's see what happens. Let's break it up into 2 square roots. And 4 is okay, because 4 is a number in this list. But I'm just telling you, the way we did it here was the best way to do it. Okay. Yeah.
Please.
Yeah, you just wait for one person to come back.
Yeah.
So let's break it up into 4 and 20. Which one of those can you take the square root of in your head? Yeah.
You can do both.
Well, which one can you do and get like an exact and get a nice answer? Yeah. Which one?
20. I mean, actually 4.
Yeah, what's the square root of 4?
I guess 2.
2. Now, problem with that one is you didn't do anything wrong, but since you picked 4 and 20, that wasn't the best number to pick. It's still okay, but now you've got to break up 20. So the 2 is going to stay right where it is, and let's break this up into 2. Does anybody remember how we broke up 20 earlier? Yeah.
4 and 5.
4 and 5. Now we have a square root here again that we can simplify. Anybody see what's the square root of 4 going to give me? Square root of 4, yeah. That gives me a 2. Okay, so I've got a 2 times 2. That's a 2. That's a 2. And I can multiply the 2's together in front. So what do I get if I multiply, Colin, how about 2 times 2? What's that going to simplify to in this step right here? Well, what can we simplify?
The 2's?
Mm-hmm. And what would they simplify to?
4.
4. So we just simplified the square root of 80, and we got 4 square root 5. Look at what we got on the other page. 4 square root 5. We get the same answer. Okay. The difference is doing it this way was 1 step. Doing it this way was like 3 steps. Right? It was more steps. But if you start out with a square root and you don't break it down and you don't use the best number that you could have, that's okay. You just may have to break it down a second time. Right? But we always try to pick a number in this list. Right, let's do one more of those. How about square root of, let's try, square root of 75. Can anyone give me a way that you can break up the number 75? And it's got to be a number that's in that circled list. Yep, 25 times what gives you 75?
3.
Perfect. Yep. You can break that up into 25 times 3. So we put 2 square roots, and then 25 times 3 is 75. To give like 3/4, right? 75 cents. And what's the square root of 25? 5. There you go. Okay, so that's how you simplify, at least that's how I simplify a square root. All right, so the next thing, and I know this was something people were working on in geometry, is what happens if you have a letter raised to a power? Well, the idea is you're going to rewrite it, kind of like we did up above, but you're going to rewrite it using as many powers of 2 as possible. Okay. So let's see how we would do that. So let's start with x to the 5th. I want to rewrite that with as many powers of 2 as I can. So I can definitely start off with 1 power of 2. Can I multiply by another x to the power of 2 and still have my exponent be under a 5? Yep.
Yeah.
Yep, I can do another one. Can I multiply by another x to the power of 2 and still have my exponent be under a 5?
No.
No. If I do, I'm going to get x to the 6th. Because remember, when you multiply these together, you're adding the exponents. Okay. So let's add up what we've got so far. What's 2 plus 2? 4. What do I need to make this exponent to get a 5?
1.
I need it to be a 1. That's all you have to do in this step. You're just trying to write it with as many powers of 2 as you can. Right, let's try the next one, y to the 4th. Can I write y to the 4th with at least 1 power of 2? Yep. Can I put another y to the power of 2? Yep.
Can I use the bathroom? Nobody's coming back. What time do I have to?
Yeah, technically 2:20. So yeah, you can go ahead. Yeah, that's okay. Yep.
Yeah, you can put a second one.
You can put a second one.
You cannot put a third.
You can't put a third one, right? Because you have to add these together. You don't want to go over this number. Do I need another y on the end, like I had here to the first? Nope, because 2 plus 2 gives me 4. So that one's done. Okay. Let's look at z to the 7th. So we're going to break that one up. Caleb, when I break up z to the 7th, can I break that up with at least one z to the power of 2?
Yeah.
Yep, we can do 1 times. Can I do another z to the power of 2? Yep. Okay, remember, we're adding these together and we don't want to go over that number. Can I do another z to the power of 2? Yep. Can I do another z to the power of 2? No, I'd go over. So 2 plus 2 plus 2 gives me how much? 6. But I need to get a 7. So what is the exponent on my last z? It's a 1. Yep. That's the first part. That's the hardest part. If you understand how to break this up into powers of 2, then the next part is easy. So now, for each letter that has a power of 2, when we take a square root, it's going to make this number that I just circled disappear. But only if it has a 2 on it. If it has a 1 on it, no, it doesn't disappear. But if it has a 2, it's going to cancel it out. Okay, so let's try the first one we did, x to the 5th. But now we're going to take the square root. And everything that we just wrote down for x to the 5th, that's going to go right underneath it. x2, x2, x to the 1st. X times. And then for each letter that has a power of 2, the square root and the 2 are going to cancel out. So let's look at the first one. Does the first letter have a power of 2? Yes. Then the square root and the 2 are going to cancel, and what's going to be left? Just an x. Let's look at the second one. Does that have a power of 2? Yep. Then the square root and the 2 are going to cancel, and what's left? X. Does the third one have a power of 2? No. Then that does not cancel. That last square root has to stay with the x in it. It didn't have a 2. If that was a 2, it would have canceled like all the others. But since it was a 1, the square root stays with the x in it. That's what they're looking for. Let's try the second one. How did we break up y to the 4th? Up above. Yeah.
2 twos.
So,
Y to the 2nd.
yeah, y to the 2nd,
2 of them.
and y to the 2nd. Right up here. Okay. Does the first letter have a 2 on it?
Yes.
Yes. So the square root and the 2 cancel, and what are you left with?
Y.
Just a y. Does the second letter have a 2 on it?
Yes.
Yes. Then the square root and the 2 cancel, and what are you left with?
Y.
A y. Now, one thing we can do is we can combine those together. When you multiply y times y, what do you get? Y to the what? Second. Yep. That's probably how they want the final answer on IXL. So I guess we could do the same thing here. The square root of x, that's going to stay. But what's x times x? X to the power of 2. So I think on the IXL, they would want it the bottom way that I circled. Okay. Let's look at z to the 7th. How did we break up z to the 7th power? Yep.
Z to the 2nd.
Z to the 2nd.
Second.
Z to the 2nd.
Z to the 2nd and Z to the 1st.
Z to the 2nd. And z to the 1st. Okay. Does the first z have a power of 2?
Yes.
Yep, so the square root and the 2 cancel, and what are you left with?
Z.
Z. What's going to happen on the second Z?
Go cancel out.
And what are you left with? You're left with a Z.
For
What's going to happen on the third Z?
Go to cancel, it's a Z.
It's going to cancel and it's a Z. What's going to happen on the fourth Z?
It's a times Z to the first.
We still have that Z to the first. So does the square root cancel anything out? No. Then the square root stays right where it is. This Z doesn't have a 2. That's why it has the square root instead. But what about Z times Z times Z? What's Z times Z times Z going to give you? Yep. Z to the third. And we don't combine anything that's outside a root with anything that's inside a root. Why is this Z still inside the root? What was it missing? It was missing the 2. The only way it can come outside is if it has a 2. If it doesn't have a 2, it stays inside. All right, let's look at. All right, so we did one with just numbers, we did one with just letters. Let's look at one with numbers and letters. And actually, this is square root 75. We already did that, so we'll just do it again. Okay, so when you're dealing with numbers and letters, it's the same idea as doing it separate. We're still going to break it up as much as we can. Let's start by breaking up 75. Yep, we can break that up into a 25 and a 3. So that's the number part of the problem. Now let's do the letter. A to the 6th. How can we write a to the 6th with as many powers of 2 as possible? We can do an a to the 2nd. We can do another a to the 2nd. And another a to the 2nd. All right. So now we'll simplify each one and see what we get. What's the square root of 25? 5. There's no more square root there because you took the square root and you got a 5. Square root of 3, can we simplify that?
Just 1.
Can we take the square root of 3 in our head?
No.
No. Yes. According to the principle, if it's an emergency, yes. If not, then no. So I'll let you decide if it's an emergency. The square root of a to the 2nd, a to the 2nd, a to the 2nd. Okay, what's going to happen with this square root and the first a to the 2nd? They're going to cancel out, and we're left with just an a. How about the second one? That's also an a. And the third one? That's also an a. So we have a 5. We have the square root of 3. And what's a times a times a? A to the 3rd. So you can write the final answer like that, or if they want everything that doesn't have a square root altogether, you can put that right next to that. Put the 5 next to the a to the 3rd, and then put the square root of 3 at the end. That's just called reordering it. It's the same thing, it's just in a different order. Let's try, I don't know if we'll do all of them, but let's try this one. Square root of 12. Can anyone tell me how you break 12 up? Yeah?
4 and 3.
Okay. Break it up into 4 and 3. And how about q to the 10th? Are you writing it down? Do you have a pencil? Yeah.
What?
Do you have a pencil?
Yeah.
Okay. How do we break up q to the 10th?
Q times that Q to the 2nd power.
And how many of them?
5.
Yeah. you're going to have 5 of them. And because they all have powers of 2, they are all going to cancel out. What's the square root of 4? 2. Square root of 3, we just talked about that earlier. You can't do anything with it. What happens with the first q to the second? It turns into a what? Yep, that first one turns into a q. In fact, they all turn into a q. Okay, so what's q times q 5 times? Q to the 5th. So again, we've got, this isn't under a square root. That's done under a square root. They usually write those two things next to each other. So how would you write your final answer? 2q to the 5th, and then next to it? Square root of 3. Again, that's not really doing any simplifying. You're just reordering the problem. The other two are pretty similar, so let's do one that's a little different. Okay, let's try the one where it's approximating radicals. So to approximate a radical, this chart is going to help us out quite a bit. Okay? The goal is to first figure out, using this chart, what two numbers it is between. So like, if I said to you square root of 20, look at this chart, and let's see if we can figure out what two whole numbers the square root of 20 is between. What times what is smaller than 20? Multiplying two numbers that are the same. Yep.
4 times 4.
Okay, 4 times 4 is too small. So the square root of 20 is bigger than 4. But then what times what is too big? 5 times 5 is too big. So the square root of 20 is somewhere between 4 and 5. Because you're looking at the number underneath here. And I gave you a 20. Yeah. Yeah, well, it's somewhere. Yeah, we got to figure out where it is. So we're going to figure it out by multiplying. Okay, and I'll show you how we do it. Okay, so let's try the square root of 50. What times what is too small? A number times itself that's smaller than 50. Okay, 6 times 6 is 36. Can we go any bigger? 7, what's 7 times 7?
49.
Okay, 7 times 7, that's actually pretty close. 7 times 7 is too small. What times what is too big? 8 times 8. That's too big. We're trying to get 50. So the answer is somewhere between 7 and 8. What do you think it might be? Like 7 point... what do you think we should try? Yep. 7.5? All right, let's try 7.5. We try 7.5 times 7.5. That's 56, so a little too big.
7.2.
We could try like 7.2 times 7.2. All right, 51.
05.
We're just going to go to the nearest tenth. So what's the only other one we could try that's smaller?
7.1 times 7.1.
Let's see if that's closer. Yeah, that's a little bit closer. 7.1 times 7.1. So that is how you estimate it. Okay. And let's try square root of 75, last one. What times what is too small? When you're trying to do a number times itself.
8 times 8.
8 times 8 is 64. That's too small. What times what is too big? 9.
9 times 9.
Yep, too big. So it might not always be right in the middle. What do you think we should try? 8 point what? 8.5 times 8.5. Okay, a little bit bigger maybe. What's a little bigger than 8.5? 8.6 times 8.6. All right, and let's try 8.7 times 8.7. Which one's closer? 8.6 or 8.7?
8.7.
Yeah, 8.7 is only 0.69 away, so I would go with that one. Okay, so that's how you estimate a square root if you didn't have like a square root button on your calculator. Okay. So just use this chart, and that'll help you.